Hello my dear students, I hope you all are doing good. As like every time I say stay home and stay safe, so it's the same that I would say today as well. So hope you all are having very good time and good day. So now let's have a better time here with this section, Rotation and Revolution, Chapter 3. As earlier class we already did with rotation, today let us deal with revolution. As this has already been discussed in your junior classes that what revolution is, and I'm sure everyone knows the definition of it, but just let's come and talk about it once again. Revolution, what it is. Revolution is a movement of the earth around the sun. So this is where we need to understand that the earth is going around the sun. So this point you need to emphasize, and this is the very thing that differentiates from rotation. So once again, that revolution is the movement of the earth around the sun in its orbit. It takes 365 1/4 days to complete one single rotation. And during its entire journey, that is with completing one whole round around the earth in its orbit, the major effect that we see of revolution is seasons. We experience various types of seasons. Like in common or in general we say winter, summer, spring or autumn. It is all because of the revolutionary movement of the earth. Now as we did say that revolution takes place around the sun in its orbit. So what is orbit? Orbit, we say it's a path along which the earth revolves. The path, in simple, it is the road along which the earth keeps on moving around the sun. So this is where it sticks. The sun keeps holding the planets through its gravitational attraction, and hence they remain in their own orbit. So round the sun, when the earth moves, it does not deviate away from the orbit, as it is equally holded by the gravitational attraction. While the earth moves around the sun, there are two phases where this earth happens to either move very far away from the sun, or in another instance it happens to come very close to the sun. So in these two occasions we discuss this with the word as epihelion. Helios means the sun. Ep or epi means far away. So epihelion means it is the farthest distance between the sun and the earth, or you can also say as the maximum distance between the sun and the earth. And this epihelion is experienced on 4th of July. With the maximum distance the earth moves away from the sun is 152.5 million kilometers away from the sun. This is its farthest distance. While the sun comes very close to, in fact the earth comes very close to the sun on 3rd of January with a distance of 147.5 million kilometers, and this is known as perihelion. While the average distance between the sun and the earth is 150 million kilometers away. So epihelion and perihelion. Now let's once again emphasize this point. 4th of July, epihelion. 3rd of January, perihelion. 4th of July, summer season. January, winter season. Now you must be wondering what? That how is it possible that in summer season the earth is very far away and we are feeling hot? January, the earth is very close, but we are experiencing winter. So how does it happen, or why it is happening? So to answer this, you will very easily find that this is happening because of the inclination of the earth's axis. Like in rotation we discussed that the axis is inclined. It's inclined to 66.5 degree to its orbital plane and only 23.5 degree to its vertical plane. So again, further to discuss this, we will discuss the points or the topic inclination of the earth's axis. Now out of this, what we find 365 is okay, fine, 365, but where is this 1/4 gone? Where is it gone? What do you find with 1/4 is, you see that every fourth year, which is the number which is divisible by 4, in fact, every fourth year, what happens is, the calendar year comes with 366 days. The calendar comes with 366 days. Now the year which has 366 days, you will see a day is added in the month of February. So February becomes a month of 29 days. Such a year is known as leap year. So how is this added? You see, you take this 1/4 for 4 years. And you guys are very good in mathematics, so you can find it. 4 is your LCM being the denominator, and then 1 plus 1 plus 1. 4 ones, you add, you get it 4 by 4. 4 divides 4 one time. So this one single day is added in the month of February to make it 366 days, and hence we call it a leap year. Now let us talk about the inclination of the axis and its effect. So inclination of the axis and its effect, like I already discussed that July and this January with ephelion and perihelion. Let's see inclination of axis and its effect. So what do you see? Like I said, that the Earth's axis is inclined to its orbital plane with 166.5 degree, while to its vertical plane it is inclined away at 23.5 degree. So we can see this. The orbital plane means the orbit and its plane, the plane in the middle, you see. This plane is called the orbital plane. So here when we measure, this is the axis. This is the axis. So to its orbital plane, the axis is 66.5 degree. While to its vertical plane, this is a vertical line. To this vertical plane, it is only 23.5 degree. And because this inclination, what we see, and the fact about inclination is, the axis remains fixed, inclined to one particular position. It does not change its inclination, or inclined position of the axis is fixed to only one direction. So what does this inclination of axis causes, or what is its effect? We see some days are very long while nights are short, and some nights are very long while days are short, as it happens in winter and summer. Now you see, this is summer season. Days are long while nights are short. But during winter season, days get shorter while nights gets longer. And this is because of inclination of the Earth's axis. And also this axis causes variations in the seasonal activities that we see all around. So for today, let's keep it until here. We will further discuss about the seasons in details in the coming class. Thank you, and you all have a good day.